Okay, we're going to solve Objective 18 today. We are going to solve rational equations. Remember that rational means fraction. The expression can be written as a fraction. So that's going to go into our definition of rational equations. Rational equations are equations that contain one or more rational expression. So basically, we're looking at equations that contain fractions. Here is a step-by-step guide to solving a rational equation. Step 1, ooh, yuck, gross, disgusting, nasty fractions. Let's get rid of them. We're going to multiply every term by a common denominator. So we're going to get rid of our fractions. Once we get rid of the fractions, we will then determine if it is a linear equation or if it is a quadratic equation. How do you know if it is linear? If it is linear, x will be raised to the first power. The highest degree you see will be 1. And if it's a linear equation, you're going to solve it like any normal linear equation. You're going to get your variables on one side, you're going to put your numbers on the other, and you will solve. You'll combine like terms, and you'll just solve. So you will isolate the variable and solve the equation. If it is a quadratic equation, you will see an x squared. The highest degree you will see will be 2. And you will have to solve using one of the 4 methods that I taught you last week. You will solve by graphing, factoring, using the quadratic formula, or completing the square. So we're going to look at example 1. And I'm just going to let you copy that down before we go to lunch. And when we get back from lunch, we will talk about it. All right, we're going to pick back up with example 1. Okay? I asked you before lunch if anybody had any ideas on what the common denominator is going to be, because that's what we're going to do, is we're going to multiply by a common denominator, and we're going to cancel out the fractions. So, what do we think? What's 3? 18 times x plus 3. You got to do your monomials with your monomials, and your binomials with your binomials. So what are our monomials in the denominator? 18 and 6. So look, what can 18 and 6 both fit into? 18. Always think the multiple. Think the bigger one, not the factor, right? So 18, I agree. And then you also need a x plus 3. So we're going to multiply everything by 18 times x plus 3. So when I multiply it to this first fraction, we're going to start slow, and then we'll be able to kind of take it quicker. We'll have an 18, we'll have an x plus 3, and we'll have a 4 up top over an x plus 3. Because this is like over 1. Does that make sense, what I did? Okay, and then when I multiply it to the second fraction, I will have a 18. I'll have an x plus 3. What else will I have? A 5 over 6. I have the same fraction. I'm just multiplying 18 times quantity of x plus 3 to it. Okay, when I multiply it to the third fraction, I will have an 18. I will have an x plus 3. I'll have a 23 over an 18. Any questions on how I did that? How many followed with me on that? Okay. All right, what are we going to do now? Simplify and cancel things. Okay, so what can cancel here? All right, so what will I have left? 18 times 4, which is 72. Okay. What about the second one? What can simplify or cancel? The 18 can make a 3. The 6 can become a 1. It can reduce. Okay? So let me ask you this. I've got a 3, an x plus 3, and a 5. How can I multiply together 3 things all at one time? Well, first of all, you can't do it all at one time, right? So what do? You take 2 of them, put them together, and then times that answer by the third thing. Which 2 do you want to put together first? The 3 and the 5. Things that match, okay? I mean, you could distribute 3 to the x and then 3 to this and then distribute the 5 to whatever that would be. But I would do the 3 and the 5 together and get 15 times x plus 3. Okay? How about this guy? 18. And so we're left with 23 times x plus 3. So my question to you now, we've canceled out our denominators, right? What's step 2 on our steps to solve? Is it linear or is it quadratic? This is just a basic x to the first power linear equation, so solve it. Take a minute and solve this equation. So you end up with 48 equals 8x, so what's x equal to? 6. Now we got to check it just to make sure it's not extraneous. What could x not be in this case? X cannot be equal to negative 3. Now you don't have to state that. We just got to make sure our answers are okay. Is 6 an okay answer? Does everybody understand where I got x cannot be negative 3? From right here. Oh, because if x were negative 3, what would that denominator be equal to? 0, and it would be undefined, and that would not be possible. Okay, so 6 is okay. 6 is a good answer. What could you do to check it? You can plug it in, work this side out, work that side out, make sure the two sides are equal. Okay, no. Since we covered that in the beginning of class. Okay, any questions? So step number 1, we're going to, ooh, yuck, gross, disgusting, nasty, fractions. Let's multiply by a common denominator. What will my common denominator be? 48 times quantity of x minus 4. Very good. So 48 times quantity of x minus 4. So I'm just going, and that's over 1. So I'm just going to multiply to each one. And you don't have to have common denominators to multiply. So you just multiply straight across. So at the first fraction, I'll have a 48. I'll have an x minus 4. And I'll have a 7 over 12. Any questions on that? When I take it to the second fraction, what will I have? 48 x minus 4 and a 9 over x minus 4. And when I take it to the third fraction, I will have a 48, an x minus 4, and a 55 over 48. Okay, then what do? Cancel. So over here, things don't exactly cancel, but they can reduce. What can reduce? Okay, so the 48 can become a 4, and the 12 can become a 1. Now again, you got 3 things up top. How do you multiply them together? You can't do all 3 at once. Okay, I would do the 4 and the 7 first. What would that give you? 28. Whoops. 28 times quantity of x minus 4. Okay, here what will cancel? X minus 4s, and what's 48 times 9? 432. And on the other side, what will cancel? 48s, so you'll be left with 55 times x minus 4. Is it linear or is it quadratic? Is it x to the first power, or do you see x to the second power? It's linear. Okay, so you're just going to solve it like normal. So go ahead and solve it, see what you can come. $112. $320. So you get 27x, if you move this over, equals 540. And when you divide by 27, what does x come out to be? X equals 20. Okay, how many got 20? My question is, do you know, can I help at any point? Where did you get down to? So where did it become different at? Did you get 28x minus 112 plus 432 equals 55x minus 220? Did you get that part? Okay, so let's try one on our own and see where you go with that one. Okay? Yep, I can wait. So try this one on your own. I'll give you a couple minutes. All right, here we go. So do we all agree with that the common denominator is 10 times quantity of x plus 2? So far, so good. So when you write it out, you end up with 10 times x plus 2 times 2 over x plus 3 plus 10 times x plus 2 times 3 over 2 equals 10 times x plus 2 times 19 over 10. Yep. Ah, thank you. Watch this. Close enough. Yeah, it did. It just didn't go very well. It's a really bad 3. All right, thank you very much. All right, so what cancels here? X plus 3's, and so what are we left with? 20. Okay, on this one, they don't really cancel, but they can simplify and reduce. This becomes a 5, this becomes a 1. Everybody says, hey, now, what do? I got 3 things. Okay, now Jenna took the 5 and she distributed, and I'm going to do it her way just to show you could do it other ways. Okay, she took her 5 and went ahead and put these two together first. She said 5x plus 15, and what would that be times by? 3. And that's going to work. It's going to be fine. Okay, you take any two of them, put them together, get an answer, and then multiply that answer with the third part. That is like probably the #1 mistake where people go wrong, is they seem to try to, like I see most of the time they want to distribute 5 to this and 5 to this, and then they want to do 3 to this and 3 to that, and then they want to add and like combine like terms, and it just doesn't work like that. Okay, so here the 10s cancel, and you end up with 19 times x plus 3. So far, so good. So then I'm going to go ahead, and this will be plus 15 plus 45, 19x plus 57. Yes? Okay. Then I'm going to combine like terms, and that's going to make 15x plus 65 equals 19x plus 57. I'm going to move my 15x over here and subtract 15x. And so that's going to make 4x. And I'm going to move the 57 over here and subtract 57. And that's going to make 8 on this side. And then when I divide by 4, x comes out to equal 2. It's really bad 2, but it's 2. Okay? Do we know where we went wrong if we went wrong? Okay. All right. So my goal is to get through example 5 today. So just in case you're counting with me, have no fear. You will not have any homework. I just want to get through these next 2 examples. So stick with me. Does that sound all right? Okay. So I want to, let's look at this problem first. First of all, I will say, you know how sometimes students, like, they can get the bigger problems, but it's the littler ones that, like, confuse them. So don't look at this and be like, oh my gosh, so big. To me, this one might almost be slightly easier than what you just did, because sometimes the ones we just did with the monomials and the binomials, and it gets all confusing. So there's 2 things up there that I want us to address. What 2 things do you think is going to have to happen? I love the fact that you said subtraction. What do you mean subtraction? We don't subtract. We add the opposite. So first things first, when you get going in this problem, I'm going to tell you, people tend to just like make this minus x squared and bring everything else down, and that's just a huge no-no. So the very first thing I do, I agree. I would take this negative and I would do what with it? I would change it to a positive, and then I would distribute it to this guy, and the next guy. And I would change all my signs. I would copy, change, change. Does everybody understand that with me? So anytime you have subtraction within the problem, you need to add the opposite. Okay? All right, second part. What are we going to do with that big trinomial denominator? Break it down into binomials. Yeah. So before you can find common denominators, let's break this guy down. So 2x over x plus 5 plus negative x squared. Do I need to worry about factoring this top trinomial? No, because we're working on a common denominator. Okay? So I am going to factor this denominator into what and what? X plus 5 and x plus 3. So tell me, what are we going to multiply by? An x plus 3 and an x plus 5. Question. Because basically that negative goes to the entire fraction. So you don't want to take it to the negative up here and the negative down here. You just take it to one part of it. And so generally we always take it to, generally you leave your denominators the same because you're finding common denominators, but you'll take your signs up to the top because that's what you actually add and subtract together. Does that make sense? Okay. So we're going to times by x plus 5 times the quantity of x plus 3. So I'm going to leave you there for just a second. So let's see what Izzy got. 1 and negative 5. What's Rhea got? 1 and negative 5. Sure? And that's in the ballpark. If it's quadratic, could it be imaginary? It surely could. So let's look at it, okay? How many are up for, like, not writing so much? So I'm going to attempt to skip a tiny little step. Now, I will say this with a little disclaimer. If I lose you at this, please don't skip the step, okay? Like, if you need to, write all of this over that, and then write all of this with this over that, and then write all of this with this over that. But let's just look at it, okay? What happens here? The x plus 5 is canceled, so what are you left with? 2x times x plus 3. What happens here? What cancels? Cancel, 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 cancel. So what are you left with? Just that, right? So minus x squared plus x plus 10. You don't have to times it by anything. Okay? What cancels to the third one? So what are you left with? 3 and x plus 5. Does everybody understand what I did? I just kind of canceled in my head and wrote what was left. But if that confuses you in any way, shape, or form, please take time to write it to every single one and then cancel it. Okay, so here what we're going to do is we're going to go ahead and distribute. So 2x times x is 2x squared, and 2x times 3 is 6x minus x squared plus x plus 10 equals 3x plus 15. So here's my question. Is it linear or is it quadratic? And if it's quadratic, we will have to combine like terms and set it equal to 0 and solve it. So I'm going to start by combining like terms. 2x squared and negative 1x squared makes 1. Positive 6 and positive 1x makes 7x plus 10 equals 3x plus 15. I'm going to move all of this over, and so I'm going to subtract 3x and subtract 15. Okay, so that's going to make x squared plus 4x minus 5 equals 0. Yep. Okay. we know that you know most of the time what you are doing. Okay. Thank you for that. I appreciate that. Okay, how do you want to solve? I hear factor. Is this a good one to factor? Yeah, it would be a good one to factor. But if you don't like factoring, I'm hearing no. I want to do the formula. Is that right? Am I right? Then do the formula. Do whatever you're comfortable with. I will factor it. Just I'm going to do them different ways. Each one I do, I'm going to do them different ways to show you that they can be done different ways. But you do it your way. Okay? So if we factor this, I'd factor it into x plus 5 and x minus 1. Do we agree? Positive 5 minus 1 will give you a 4 in the middle. And so then x would be equal to negative 5 and x would be equal to 1. Now that's what Izzy and Rhea said, right? Are you sure? Somebody help me out. Bam. She is on the ball. You can't have negative 5 because it's going to make a 0 in the denominator. So what do you have to do with negative 5? Throw it out. It's extraneous. It don't work. So what's your answer? 1. Very good on getting the 1 and the negative 5. I will say that. But don't forget your extraneous solutions, okay? You got to look at what cannot be x. Okay? How many followed with me through that? Are you, I mean, how good are we doing? Thumbs up if you're great, thumbs halfway if you're in the middle, and thumbs down if you're bad. Okay? I need to see everybody doing thumbs up, thumbs halfway, thumbs down. I need to see where you're at. Okay. 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 All right. So this is going to be our last one for today. Do you have a question? Do I need to go back? Okay. No. I do think this does take a lot of steps. It's a lot of work. Now, I will say, I mean, what did we talk about at the beginning of this block? Is there a way to do this where you can skip some steps. Like certain things, there are other ways, but this way, the way I'm showing you works for every problem. Like, can I ask you a question really quickly? See if I have time. Let me just give you something simple. What if I have 2 over x is equal to 5 over x minus 1? If I have fraction equals fraction, what would be a simpler way to do this? Then you could, what would the common denominator be that you times by? X and x minus 1, right? You gotta have monomial, you gotta have the binomial. You could do what I'm doing, but if you have a problem that has fraction equals fraction, what did y'all like to do in elementary school all the time? My 8th graders always come in, and everything they do, they go, cross multiply, and I'm like, no, 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 you can't do that. But in this case, fraction equals fraction, it's a proportion. You could 5x, you could distribute the 2x, and and then solve. Does that make sense? And that might, but that only works when you have fraction equals fraction. Like this problem that we're looking at right now, you can't do that. Okay? And then there are other ways, Emily, like we talked at the beginning of the block. If you can't solve an equation, you can put this side into y equals. You can put this side into y equals, put it in your calculator, and find the intersections once I show you how to find intersections. Okay? So there are other ways, but as far as like an algebraic, easier way to show less steps, no. Okay, so what do you need to do with this guy? A couple things. Step number 1, all the denominators need to be factored. Okay, step number 2, so this is going to become 3 times n plus 1. What will happen here? I would make this a plus and take the negative to everything in the numerator. I would do that on step 1. Because if you don't do it on step 1, it's going to mess up. It's going to mess your signs up and you're going to mess up. Okay? So this is going to become 4 times n minus 1. I'm just taking out GCFs and factoring it. And this is going to become 2 times n plus 1. What would my common denominator be? 12. Everybody agree? 3, 4, and 2 all go into 12. 12 times n plus 1, and you also need an n minus 1. So I do agree. So let's see if we can not write quite as much. We'll try, right? So tell me what's going to cancel, Emily. If I take it to the first one, n plus 1 will cancel with n plus 1, and then the 12 will become a 4, and this will become a 1, so what will I have? 28n times n minus 1. Does that make sense? Okay, then when I take it to this guy, what will cancel? The n minus 1s will cancel, and the 12 will become a 3 this time, right? And so what will that make? I'm going to go ahead and put the negative 15 times n plus 1. Everybody following with me? Okay, and then on this side, the n plus 1s will cancel, and the 2 will become a 1, and the 12 this time will become a 6. So I'll have a 6 and a 3n. That'll make a 18n times a n minus 1. If you didn't follow with me on that, then you need to write it to every single one and simplify. How many are still writing it to every single one? Then do that, please. Okay, write it to every single one. Did I lose you? Okay. All right, so then what are we going to do? So I'm just going to simplify and start distributing. This will make 28n squared minus 28n minus 15n minus 15 equals 18n squared minus 18n. Are you with me so far? All right, then is this quadratic? Yes? Okay. So let's set it equal to 0 and combine like terms. So I'm going to go ahead and move this stuff over here. So this will be minus 18n squared and plus 18n. So I need to combine all of this. That'll make a 10n squared. What's all of that combined? Negative 28n minus 15n plus 18n. Minus 25n? I agree. Minus 25n minus 15 equals 0. And then how do you solve it? Graph, factor. You could take out a GCF. You can complete the square. You can do the formula. So that's where I'm going to leave you for today. I want you to finish this up for me, and we'll talk about this when you get back on Monday. Okay?